Better be ready. Trapezoid. That's it. Just trapezoid. It's not a exciting quadrilateral. It only has one property. Okay? Only has one property. And that is one pair of opposite sides are parallel. That's it. That's all it has. Trapezoid only. One pair of opposite sides parallel. Quiz time. If I put this on a graph, what formula would you need to prove these two sides parallel? Woo! Don't say a word. Starting off strong, 18. Darn right, slopes. Prove the slopes equal. We're going to do that at the end of class. Okay, so if I threw this on a graph, you would use the slope of this line, show they're equal. All right, so not that great. But wait till we get to the souped up version. The isosceles trapezoid. The 2.0 version. This has a lot of features. It still has one pair of parallel sides. Can we give those names? Do you mind? Can we get them a good mathematical vocabulary term? Instead of calling them the parallel sides for a trapezoid, those are called the bases. Those are called the bases. And since it's isosceles, what's isosceles mean to you guys? Two sides are congruent, right? For isosceles triangle, two sides are congruent. So the sides that aren't parallel are congruent. Isosceles trapezoid. The two non-parallel sides, can we stop calling them non-parallel sides and start calling them legs? Those are the legs, are the congruent sides. Bases are parallel, legs are congruent. Notice my first theorem. If the trapezoid's isosceles, the base angles are congruent. Base angles. Do you think you could mark with arc marks what you think are a pair of base angles? So go ahead. You may have to erase them or cross them out. Who knows? But go ahead and mark two angles which you think are your base angles. I'm going to assume most of you did this. Yeah? Base angles. There's another pair. There's another pair, the top pair. Okay, both pair are congruent. All good? Base angles are congruent, and the final theorem that it doesn't have many properties, but diagonals are congruent. Okay, diagonals are congruent. Does the theorem say they bisect each other? Anybody see that? No. Does it say they're perpendicular? No. The only thing you have is that they are congruent. Quiz time. Name two other figures that are also congruent. Name two other figures where the diagonals are congruent. In this quadrilateral unit, we've talked about two other figures where the diagonals are congruent. Uh-oh. 6. One of them. Rectangle. And 5. I know you weren't here, but it's the figure that has everything. Rectangle, rhombus, what's underneath them? Begins with an S, ends in square. Good, square. Everybody good? Rectangle and square. All right, rectangle and square. But what's the difference? Do these bisect each other in isosceles trapezoid? No, it is not a parallelogram, so they do not bisect each other. Algebra time, here you go. Whew, we're getting nervous, I know. No, we're getting nervous. Big test Tuesday, even bigger one 2 weeks from tomorrow. All right, find the x for me here on number 1. Find x. I threw in an extra one there you didn't need. Definitely an isosceles trapezoid. Someone set up an equation for me to find x. Let's roll. 22. Who gave that one to me there? Dylan, you give that one to me? Calm down. I said, did you just give that to me? Okay, thank you. Nice job. I was going to compliment you. What's your prediction on the midterm? Score. Yes. Ooh, all right. Okay. X equals, go ahead, Dylan. X equals 4. Yep. 90. Boss. Okay. We'll see. Next one. Now I realize I just gave you base angles are congruent. So you can say that 6x plus 20 is equal to y. Now we want to stay away from that though. Don't really want an equation with two variables. So the only way we're going to accomplish that is if I know the relationship between those two. Not a property I gave you, but a little midterm review. Those lines are parallel. You got to know what those are called in 2 weeks. What type of angles are those two called if those two lines are parallel? Here we go, digging deep. Period 1 got it, just throwing that out there for the challenge. What type of angles are those if those lines are parallel? Uh-oh, not my number. 24? I don't know.
No, I know, but it doesn't matter.
All right, 25 now. All right. Same side interior. Congruent or supplementary? Supplementary. 6x plus 20 plus the 4x equals 180. This is not really an isosceles triangle property. It's just the fact that those are same side interior. And when you find the value of x, let me know. Take your time though. When you're ready, 20, just let me know the value of x whenever you're ready. Ooh, right away, 16. Where's everyone going? Find the values of the variables. There's still another variable there, champs. There's still a y. There's still a y there. So now I already gave away at the beginning, base angles are congruent. Find a way to find y. When you're ready. 18. $116 degrees. Yep. Goof Troop, what do you got back there? What's going on?
Oh, he's talking about.
I'm not talking.
Okay. All of our IQs are going down listening to that. Let's keep going. Wasting everyone's oxygen. Too harsh. Here we go with 3. Determine x. Great. Midterm review. Give me a name for segment x. A vocabulary term that we have used in the past. Even though we used it in triangles, we can still use it here. Starts at a vertice, perpendicular to the opposite side. What have we been calling those types of segments? 13? Altitude. Perfect. That's an altitude. This is an isosceles trapezoid, so if this leg is 13, so is this leg. What type of triangle have I created? A right triangle, yeah. So I start getting a little excited when I see the right triangle because I can always use Pythagorean theorem in any right triangle, but I got a little issue here. What's the 13? Hypotenuse or leg? Okay. What's the x? Leg. Ooh, if I could find the value of the other leg here. then I'd be on my way. Can I find that? Because once I find it, we're gone. All right, well, can I draw in another altitude on the other side coming from this vertice? Yes, I can. All right, this whole thing here was 34. Can you tell me what this piece is from here to here now? From altitude to altitude? 24. So I got 10 left. Divided evenly. That leg I'm missing is going to be 5. Yep. So I make it into a rectangle and 2 triangles. Trapezoid can be divided up into a rectangle and 2 congruent triangles. So I'll give you guys a second there to find my altitude length. When you're ready, let me know. 3 when you're ready. Got it. Good job. Any issues from you guys? And I know you're wondering, where are they? When are we going to do them? I missed them. I missed them. Where are they? Oh, you got one right here. Let's go. You're hungry now. Oh, boy. Oh, look at that. Right on cue. The old fade.
It was current one time, I swear.
All right. What are you trying to prove in this one? What are you trying to prove? 5, what am I asking you to prove here? It's an isosceles trapezoid. So look up above in the box. There are 2 different ways to prove it's an isosceles trapezoid. No matter which one you decide to go with, look at the first couple words. Before you can say it's an isosceles trapezoid, you need to show me it's still a what first? 7. Even though I know we're going to prove it isosceles, these 2 still start out with by saying you got to prove it a what first? Yeah. We're not going anywhere until we prove it a trapezoid first. Then we can say isosceles at the end. All right, move up to the box on the top. There's only one way I'm proving it isosceles. Excuse me, a trapezoid. Only one way I can show this is a trapezoid. And it gets a little nuts. 5, what's it say to prove it's a trapezoid? Okay, stop. So we need to prove DC and AB are parallel, which is doable, easily doable. But then we also have to prove what? Keep reading, 5. Yeah, we got to prove DA and CB are not parallel. That's when it's going to get nuts. So does everyone see what we have to accomplish here first? Prove DC and AB parallel, but then we're going to say DA and CB are not parallel for some reason. All right, let's get these parallel first. You can do it. You can do it. Dig deep. DC and AB, let's get them parallel. Well, it's already a parallelogram. So you already know what 2 sides are parallel right now. 10, what sides are parallel right now? Right now. AE is parallel to DC. For what reason? What did you just say? There's like a bunch of mumbling there at the end.
Sorry, parallelogram implies the opposite side.
Okay. But now how do I get that out to AB now? Oh, we got a little something, something I've shown you this unit. We got a little something, something that gets it out to AB. 15, how do I get that sucker out to AB now? Perfect. So now I can say AB, extend that thing out to AB, is parallel to DC. extensions of parallel lines. They are parallel. Nice. So that was not bad. That was just a little review to get them parallel. This is the worst part of my year right now, at this moment on this day, is showing you why DA is not parallel to CB. All right, because it's one of the most non-mathematical things I'm ever going to have you write down. And it does kill me inside, all sarcasm aside. What do you guys know about parallel lines? They never intersect, right? They never intersect. But if I kept DA and CB going, DA not parallel to CB, what would happen if I kept drawing them out? They would eventually intersect. They will eventually intersect. I know, very mathematical, pains me, but it is what it is. So that's how you can show they're not parallel. Just say, hey, they're eventually going to intersect. Or if they do intersect, tell me they intersect at whatever point. All right, what do I have now? What is ABCD? Trapezoid, yep. ABCD is a trapezoid. And don't be that kid that abbreviates trapezoid and is like, oh, look, ABCD is a trap. You're not funny, just funny looking, all right? Why is it a trapezoid? What did we just prove above? In your own words. 14, in your own words.
One pair of opposite sides are parallel and another pair is not parallel.
Correct. One pair of opposite sides parallel, and the other pair is not. Implies a trapezoid. All right, now how do I get it to be isosceles? One of two ways, and you're going to decide with people around you what way you want to do. Now that's a trapezoid, you can get the legs congruent, if you can get DA congruent to CB, or a pair of base angles congruent. It makes it isosceles. That's what I'm going to leave you and the people around to discuss. Okay? Get the legs congruent, or get a pair of base angles congruent. Go. Decide on what you want to do. Get the legs or base angles congruent to make this sucker isosceles. Both can be done. The legs can be proven congruent, and the base angles can be proven congruent. Both could be done. Just a matter of which one you chose. So I'm just going to listen to number 24. Which way did you do? Legs or base angles? Legs. Did I have any base angles, people? Just one? Okay, we'll talk at the end, Logan. We'll talk at the end. Okay, since everyone was proving the legs, what did I need to do first to get the legs congruent? Here you go, 12. What do I need to do first to get the legs congruent? DA and CE, yes, they are congruent. Didn't have to put that first, but it had to come eventually. Why are they congruent? Yep. Also needed what before proving the legs congruent? Needed one more step before saying the legs were congruent. 21. What was it? CE congruent to CB. That is a correct statement. Was it CE and CB? Why back there, young one? Yep. And then we did a little thing called what on step 6 and 7 to say DA is congruent to CB. We did a little thing we like to call 8, substitution. So we called it a trapezoid. We proved it was a trapezoid. Now we proved the legs are congruent. That makes it a isosceles trapezoid. What's a nice little reason, in your own words, why is it isosceles trapezoid? 5. Need more, because I could show you another figure that's only got 2 sides congruent. What made it isosceles trapezoid? In addition to legs being congruent, what else did we do? There you go. So a trapezoid with congruent legs or base angles congruent implies isosceles trapezoid. Logan, how'd you get those angles congruent, stud?
So that the angle A is
Yep.
equal to angle C.
Because they're what type of angles?
Corresponding.
Good. And then how'd you get A and B?
Substitute.
Substitution done. Good. Any questions from you guys there? Okay, can we go to the last proof, the coordinate proof? I want to make sure we don't run out of time to do that one. Quick heads up. When you're graphing, there are no negative coordinates, so you don't have to do it down the middle. Okay, you need 13 on the x-axis and 9 on the y-axis at least, so make sure you're smart about how you set up your x and y axes. All right, there's no negative x value, so don't worry about doing it straight down the middle here. Okay, just make sure you got 13 to the right and at least 9 units on top when you graph it. What's going to make that a trapezoid? Because that's all we can forget. We don't have to do isosceles here. This is nice. I just have to prove it a trapezoid. So what are the 2 things needed to show that's a trapezoid? 12. Okay, hold on. So I got to at least show this. Everyone agree? Got to at least show that. And I also have to show the other pair not parallel. And they'll eventually intersect. Not going to cut it on this one, because you can mathematically prove to me that they're not parallel now. All right, so when I put it on the graph, I'm not going to accept, oh, they will eventually intersect. No, baloney. You can tell me they're not parallel by doing it mathematically. All right, so I'm saying this word parallel a ton, which means I got to bust out what formula? 5. Slope. So here we go. Step 1. Let's find the slope of AB. Someone's going to be responsible for the slope of AB. Y over X, or you can do rise over run, since you already graphed it. Up and over how many for AB? Up and over how many? 13. Up and over how many? 8. So from A to B, up how many and over how many? So up, first answer, ready? Up. 3 over, there we go. Got it. 3 over, is that positive or negative? Not off the hook yet. Positive. I'll reduce it down to 1/2. All right, let's do DC now. From D to C, up and over how many? When you're ready. Oh boy. Always 21. How'd you get down to that? Because it's not up 1 over 2, tough guy.
It's up 5 over 2.
There you go. Positive or negative?
Wait, yes.
Oh boy, it's always painful. Wow. Okay, I'm still not, I know those are parallel, but we also had to prove these are not parallel. So what else should I do on these sides? Slope, and show they're not equal. That's why I don't want you guys to say they'll eventually intersect, because you can mathematically say, hey, the slopes aren't equal. So go ahead, slope of AD. Oh boy. Up and over how many? 19. Here we go. Up and over. Do I have a 19? Oh, okay. No problem. What do you got for me? Yep. -5 halves. Perfect. And then how about the slope of somebody? Slope of BC now.
We just said somebody, and then you just wanted to call them.
I liked you better when you were not here on Friday. Too harsh? Too harsh? Dylan, you might want to give your boy Mike here the invention we discussed a couple weeks ago. The comb, yeah. You all right, Mike? That thing's out of control.
Oh god.
You all right with the hair? It's a little rough morning, or?
Yeah. Does it come like that?
Okay. We good?
Yeah,
All right.
come on, slide it, slide it.
Don't touch it.
Are we done? Okay.
Why do you have a
All right, that just took a turn I didn't want, but all right. All right, here we go. Step 2 is always, what did we just learn? We did not learn it was a trapezoid yet. What did we learn? 2 things you should learn from step 1, doing all those slopes. Just give me one of them. 6, 1 out of the 2 things we learned.
So they're not parallel. AD and BC are not parallel.
Thank you. AD is not parallel to BC because slopes are not equal. And the other thing we learned. 16, one other thing we learned. Why? Yep. All right, so one pair is parallel, the other pair is not. We can now say it's a trapezoid because one more person to end this day on a good note. 25.
Because one pair of opposite sides is parallel, the other is not.
Perfect. One pair of opposite sides parallel and the other is not. Nice. That's the huge part. Kids always forget. Got to prove them not parallel as well. All right, that's it for the quads. Tomorrow we just do a couple more coordinate proofs to make sure you're good with those. But we're done with all the figures. How am I going to study for this test in 2 weeks? Study for the quad test like you're going to attack the midterm. Get your playlist ready. Get your outfit already picked out.